The farthest machine humanity has ever built is a spacecraft called Voyager 1. And here is the strange part. Nobody on Earth has ever seen it where it actually is. Voyager launched in 1977, and it has been falling outward ever since, through the orbits of the giant planets, past the boundary where the sun's wind gives up, into the space between the stars. It is still talking to us, but its voice now takes almost a full day to cross the gap. Every signal we receive left the spacecraft yesterday. Every position we plot is old news, the most distant thing our species has ever touched. And we are permanently one day behind it. Hold on to that, because that one-day delay is a crack in the floor, and this whole story falls through it. Keep pulling the camera back. Voyager shrinks to nothing. The solar system closes into a point of light. The Milky Way flattens into a glowing smear, then joins a crowd of galaxies. Then the crowd itself becomes a fleck in something larger. Keep going. Farther than any spacecraft could ever fly. Farther than any galaxy we could ever visit. All the way out to the absolute limit of what the universe has ever allowed us to see. What is actually there? A wall, a last galaxy, pure black nothing. I will tell you right now, it is none of the things you are picturing, and by the end of this, you will know exactly what sits at that limit. You will also discover something better. You have already seen it, without a telescope, possibly today. Let's go find out what it was. Start with the picture in your head, because everybody has one. You hear the phrase, edge of the observable universe, and your mind builds something. Maybe a wall of darkness, maybe a glassy boundary, like the skin of a soap bubble, with all the galaxies floating inside. Maybe just a place where the stars thin out and stop. The way city lights thin out and stop when you drive into the desert at night. Whatever your version looks like, it shares one feature with everyone else's version. It is a place, a location, somewhere a spaceship could, in principle, park. I want to be straight with you in the first 5 minutes instead of the last 5. That picture is wrong. And it is wrong in a way that makes everything ahead of us far more interesting. Here is what the observable universe actually is. It is not a container. It is a delivery record. At this moment, sitting in the archives of our observatories, is every photograph humanity has ever taken of the sky, every star, every galaxy, every smudge of light in every deep exposure. All of it arrived here the same way, as light, crossing space, landing on a mirror or a sensor or a human eye, and light, fast as it is, needs time to travel. The universe has only existed for about 13.8 billion years, which means there has only been 13.8 billion years of delivery time. The observable universe is simply the collection of everything close enough that its light has managed to reach us within the lifetime of everything. That is the whole definition. Everything we can see, not everything there is. Now, how big is that collection? Ask a reasonable person, and they will do reasonable math. If light has been traveling for 13.8 billion years, then the farthest anything can be is 13.8 billion light years. Clean and obvious. The actual measured answer is about 46.5 billion light years. In every direction. That number looks broken. It is not. And the fix takes 4 sentences. The light from the most distant regions really did travel for nearly 13.8 billion years. But while that light was in flight, space itself kept expanding, the way it has been expanding since the beginning. The regions that sent the light did not sit still and wait. By the time their light finally landed here, Expansion had carried those regions out to 46.5 billion light-years away. And that is the distance we mark on the map today. That is all the arithmetic this story needs. Other videos, including One Long Night on this channel, have taken that expansion apart piece by piece. This journey is chasing a different animal entirely. We are not here to measure the distance. We are here to answer a much more physical, much more human question. If you point your eyes at that limit, what shows up? Because notice what the definition just did to our destination. If the observable universe is a delivery record, then its so-called edge is just the line where the mail runs out. There is no wall standing at 46.5 billion light-years. There is no fence, no membrane, no last brick of creation. Space almost certainly continues past that line, filled with more galaxies, more stars, more everything. And the only reason those regions are missing from our maps is that their light has not had time to get here yet. The edge of the observable universe has the same physical reality as the edge of your flashlight beam in a dark forest. The forest does not end where the light ends, which might sound like the mystery just died. If there is no wall, there is nothing to see. And this video should be 4 minutes long. Except something genuinely strange happens when you actually try it. When you take the biggest telescopes on Earth and aim them as deep as they can possibly reach, toward the limit, toward the place where the delivery record runs out, the sky refuses to simply fade to black. The sky starts doing something else, something that took humanity by complete surprise. The deeper you look, the farther back in time you fall. Point a telescope at the limit of everything, and the universe starts running in reverse. Galaxies get younger, then they get stranger, then they come apart, then they disappear entirely. And the sky plunges into a darkness with no stars in it at all. And then, past that darkness, at the very bottom of everything we can see, you slam into the most shocking thing in all of astronomy. Light, everywhere, a wall of it, wrapped around the entire sky, getting there, layer by layer, and understanding what that final light actually is. That is the road ahead, and the first step is a fact so simple you already know it, and so strange that most people have never once stopped to feel it. You have never seen the sun. I mean that sentence literally. You have never seen the sun, not once, not for a single second of your life. What you have seen, on every bright afternoon you have ever lived, is a portrait of the sun as it existed 8 minutes and 20 seconds earlier. That is how long sunlight spends crossing 93 million miles of empty space before it lands on your face. The warmth on your skin right now, if you are outside, is 8-minute-old news. If the sun somehow shut off this instant, you would keep standing in cheerful golden daylight for 8 more minutes. Completely uninformed, because the report of the disaster travels no faster than the light itself. 8 minutes is nothing. You could boil an egg. But watch what happens to that harmless little delay when we start climbing. Look at the moon, and you are seeing 1 1/3 seconds into the past. Look at Mars on a good night, and you are minutes behind. Look at the brightest star in Earth's sky, Sirius. And the light entering your eye left that star more than 8 years ago. Everything you know about Sirius is nearly a decade stale. It could have changed. You would have no way to know. Now find the Big Dipper, something almost everyone in America can locate. The stars in that one famous shape sit at different depths, and their light is arriving from roughly 80 to 120 years back. Some of that starlight began its trip when there were no televisions, when the First World War had not happened, when your great-grandparents were children. It all lands in your eye, in the same instant, and your brain flattens it into a single picture called now. The picture is a lie. A beautiful, layered lie, assembled from different decades of the past. And we have barely left the driveway. On a genuinely dark autumn night, away from city lights, you can find a faint grey smudge in the constellation Andromeda. It looks like a fingerprint on the sky. That smudge is an entire galaxy, 1 trillion stars, and it is the most distant object almost any human eye can ever pick out without help. Its light traveled for 2.5 million years to reach you. When those photons launched, there was not a single human being anywhere. Our ancestors were small African primates, still working out what to do with their hands. Every photon that enters your eye from that smudge has been in flight for longer than our species has existed, and it ends its journey on your retina. Tonight, for free. So here is the rule, and it is the master rule for everything ahead of us. Distance is delay. Every time you look farther away, you are forced to look further into the past. There are no exceptions, no upgrades, no premium version of vision that shows you the universe as it currently is. Light is the fastest messenger that exists, and even light needs time. So every image is a delivery from history. The whole night sky is old mail. Most people hear that and file it away as a curiosity. Astronomers heard it and realized it was the single greatest gift ever handed to science. Because think about what it actually means. We can never see the distant universe as it is today. Fine. But in exchange, we get something no other science has ever had. We get to directly watch the past. A geologist studying the ancient Earth has to dig up rocks and read the wreckage. Because the ancient Earth is gone. A paleontologist gets bonds. Never the animal, but an astronomer who wants to see what the universe looked like 5 billion years ago does not have to reconstruct anything. She just points her telescope at something 5 billion light years away. And there it is. Live footage. The actual light. From the actual era. Arriving in the actual present. A telescope pointed far enough into space becomes a machine for looking backward in time. And I do not mean that as a metaphor. It is a real time machine, made of glass and metal, and you can buy parts for it. That flips our entire mission on its head. Follow the logic one step, and you will feel the ground move. We set out at the beginning of this story to travel outward, toward the edge of the observable universe, expecting to find whatever object sits at the farthest place. But distance is delay. So the farthest place is also the earliest time. The two are welded together and cannot be separated, which means the question on the title card quietly transforms. What would we actually see at the edge of the observable universe? Strip away the geography, and what the question really asks is this. What is the oldest thing that can still be seen? What is the very first picture the universe is capable of delivering to a mirror? Somewhere at the absolute bottom of every deep photograph, underneath the youngest galaxies, before the first stars, there is a final image, a last page in the album. The edge we are hunting was never the edge of space. It is the edge of seeing. That is our destination. And from here forward we are going to fall toward it, layer by layer, era by era, watching the universe get younger the deeper we go. But before the falling starts, there is a problem we have to deal with. And it is a problem with you, specifically with your eyes. Because the deep universe does something to light that human vision was never built to handle. Way out there, the galaxies are not just distant and dim. Out there, the universe changes color. Here is a fact about your body that sounds like an insult, but is really just an engineering note. Your eyes were built by a savanna. They were tuned, over millions of years, to do a very specific job, which was catching the particular slice of sunlight that pours through Earth's atmosphere and bounces off fruit, predators, and other people. At that job, they are magnificent. The problem is that the slice they catch is almost nothing. Light comes in an enormous range of wavelength. A keyboard that runs from radio waves longer than buildings all the way down to gamma rays, smaller than atoms. On that whole keyboard, the part your eyes can play is about 1 octave. 1. Everything you have ever seen, every sunset, every face, every photograph, every frame of every movie, was performed inside that single octave we call visible light. The rest of the keyboard is real, and it is everywhere. And you are blind to all of it. For most of human history, that blindness cost us nothing. The savannah broadcasts invisible light. So visible eyes were the right tool. But we are about to aim those eyes at the deep universe. And the deep universe does something cruel to light on its way here. It stretches it. Remember the master rule from the last chapter. Space expands while light is in flight. Now look at what that expansion does to the light itself. A light wave is exactly what it sounds like. A wave, with crests and troughs. And its wavelength decides its color. Short waves look blue. Long waves look red. And a wave crossing an expanding universe is like a drawing on a rubber sheet that someone is slowly pulling wider. The wave rides inside space. So, when space stretches, the wave stretches with it, crest by crest. The light gets longer. Longer means reader. Astronomers call it redshift, and it is one of the most thoroughly measured facts in all of science. For nearby galaxies, the stretching is small, a little slide toward the red. Easy to correct for. No drama. But the farther the light has to travel, the longer it spends inside the stretching, and the redder it arrives. So watch what happens as we push a telescope deeper and deeper. Because this is where the title of this video stops being a simple question. Take a galaxy a few 100 million light years out. Its portrait arrives a touch redder than reality, like a photo shot at sunset. Fine. Push to a few billion light years. The blues are draining out now, the whole image sliding down the keyboard. Push farther. The light that left those galaxies as ordinary white starlight is arriving with its visible portion shoved clean out of the visible octave. The galaxy is still there. It is still shining. Its light is still landing on Earth right now. But that light has been stretched into infrared. The octave below red. The one your eyes cannot play. Point the finest optical telescope ever built at the most distant galaxies in existence. And here is the honest report of what it sees. Nothing. A blank. The galaxies have not vanished from the sky. They have vanished from the octave. Let that settle for a second, because it quietly breaks our whole mission. The question we are chasing is what we would actually see at the limit of everything. And the first real answer of the night is this. With the eyes you were born with, aimed at the deepest sky, you would see essentially nothing at all. A blackness. And the blackness is a lie. Because the sky in that direction is full, absolutely crowded with galaxies. All of them screaming in a color you do not own. So we do the only thing there is to do. We change our eyes. That phrase is the engine of everything ahead. So I want to install it properly. We cannot make the universe send us different light. The mail arrives stretched. And no technology unstretches it mid-flight. What we can do is build new eyes on the receiving end. Eyes made of beryllium and gold, that drink infrared. Eyes made of metal horns and cooled amplifiers that catch microwaves. Eyes the size of countries. Eyes that orbit in the dark. Eyes tuned to octaves no animal has ever seen with. Every time the expanding universe shoves the light out of one octave, we build an eye for the next octave down, and the sky fills back up with things. This is precisely why the James Webb Space Telescope, the most powerful eye humanity has ever launched, was designed around infrared instead of visible light. People sometimes hear that and think it is a strange choice. Like building a race car with no windshield. It is the entire point of the machine. Webb was built to hunt the most ancient galaxies in existence, and the most ancient galaxies no longer deliver visible light to this address. Expansion has dragged their portraits into the deep infrared, so we built a deep infrared eye, chilled it to almost absolute zero so its own warmth would not blind it, and sent it 1,000,000 miles from Earth to stare. And the moment humanity opened that new eye, the blank patches of sky lit up with thousands of galaxies nobody had ever seen. Same sky, same direction, different eyes, different universe. Keep that trade in your pocket, because we are going to make it again and again. Each time the sky goes dark on us, it will turn out the darkness was a costume, and underneath it the universe was blazing away in the next octave down. The deep sky never actually ends. It just keeps changing keys. And we keep learning new instruments. So now we have the right eyes for the first descent. Infrared eyes. The kind that can catch starlight stretched by 10 billion years of expansion. We are ready to aim them at the deepest, oldest layers of the sky and finally start falling toward the bottom of the album. But before we do, you deserve to know something. The single most important photograph in this entire story, the one that first proved the deep sky was full instead of empty, was very nearly never taken. It required one of the most powerful telescopes on Earth to spend 10 straight days staring at a patch of sky that every measurement said contained nothing. It was called a waste. It was called career suicide. One man ordered it done anyway, using the one loophole nobody could veto. His name was Bob Williams, and it is time you met him. In 1995, the Hubble Space Telescope was the most oversubscribed machine on the planet. Astronomers around the world were begging for time on it, submitting proposals years in advance, fighting over minutes the way surgeons fight over operating rooms. Every hour of Hubble's attention was priceless, budgeted, and spoken for. Pointing it at anything was a decision that had to survive committees. Almost anything, because buried in the rules of the Space Telescope Science Institute was one strange exception. The director of the institute held a personal reserve of telescope time, called director's discretionary time, a pool of hours he could spend on absolutely anything he wanted. No committee, no vote, no appeal. It existed for emergencies, for sudden comets, for targets of opportunity. The director, in 1995, was an astronomer named Bob Williams, and Bob Williams had become obsessed with an idea that his own advisors thought might be professionally fatal. He wanted to take his entire reserve, 10 consecutive days of the most in-demand scientific instrument in human history, and aim it at nothing. And he meant nothing in the most literal sense available. Nothing was the target. Williams asked his team to search the sky near the handle of the Big Dipper for the emptiest available patch. A spot with no bright stars, no known galaxies, no planets, no anything. The patch they chose was tiny, about the size of a grain of sand held out at arm's length. Through every telescope on Earth, that patch was a void. Black, blank, certified empty, and the plan was to park humanity's greatest eye on that certified emptiness for 10 days straight, stacking exposure on top of exposure, 342 separate frames, letting light accumulate on the detector the way rain fills a bucket, and see if anything at all swam up out of the dark. Understand what the objections were, because they were completely reasonable. Hubble had nearly been a national embarrassment once already. Launched with a flawed mirror, rescued by astronauts in the most famous repair job in space history. The telescope had enemies in Congress and skeptics in the press. Senior astronomers warned Williams directly. If 10 days of the world's telescope produced a blank frame, the headline writes itself. A young researcher's career could survive that headline. The director's could not, because the director had no one above him to blame. Williams heard all of it and made the kind of bet that only makes sense if you truly believe the rule we installed 2 chapters ago. Distance is delay. Depth is time. If you stare long enough into a dark that has no foreground, no glare, no nearby clutter, you are staring down a hallway into the past. And the only question is whether anything was there in the past to shine. If the answer was no, he would own the most expensive photograph of nothing ever taken. He said, more or less plainly, that if it found nothing, he was prepared to take the fall. In December of 1995, over 10 days, Hubble starred 342 exposures. The frames came down from orbit one by one, and the team began stacking them. And faint smudges started to condense out of the noise like figures walking out of fog. The final image contained roughly 3,000 galaxies. In one patch of certified nothing, one grain of sand of sky, 3,000 galaxies, layered from relatively nearby, all the way down to depths of billions of light years. Spirals and ellipticals, and strange blue fragments no one could classify. Each one a city of billions of suns, each one carrying light from a different century of the deep past. All of them crammed into a keyhole that every previous eye on Earth had sworn was empty. They called the picture the Hubble Deep Field, and it did to astronomy what the first maps of the Pacific did to geography. It ended the argument about what the dark was. The dark was not absence. The dark was distance, and distance was time, and time was full. Run the arithmetic from that one keyhole across the entire sky, and the estimates land in the hundreds of billions of galaxies at minimum, with later, deeper surveys pushing the counts higher still. Every blank stretch of night above your house, every gap between the stars you can name, is packed shoulder to shoulder with galaxies too old and too stretched for your eyes. The empty patch turned out to be the single most crowded photograph ever taken. And Bob Williams, the man who bet his career on nothing, had handed our whole journey its map, because sitting in the deepest layers of his image, and in the deeper fields that followed it, were faint red dots, the reddest, oldest, most stretched things in the frame, light that had been flying for over 10 billion years, from galaxies that lived near the beginning of the album. Those dots are the doorway. Every question this video is chasing lives on the other side of them. So let's do now what Williams made possible. Pick one of those red dots, zoom toward it, fall past the nearby spirals, past the middle-aged galaxies, down through billions of years of stacked light, all the way to the bottom layers of the deep fields. Because here is what nobody expected when humanity finally reached those layers. The galaxies down there are not just smaller and dimmer versions of ours. Something is wrong with them. They are the wrong shape, the wrong chemistry, the wrong everything. The deeper you fall, the less the universe looks like anywhere you have ever been. We are about to watch the cosmos come apart, one familiar piece at a time. Before we fall, get a good look at home, because home is what we are about to lose. The galaxies in our neighborhood are grown-ups. The Milky Way is a settled, orderly machine, a disk of several 100 billion stars turning smoothly, its spiral arms combed into place by billions of years of rotation. Andromeda next door is the same kind of citizen, big and calm and structured. Look around the local universe and this is the norm. Majestic spirals, massive golden ellipticals, galaxies with architecture, with routines, with stable orbits their stars have repeated for eons. Galaxies that have had time. Time is the key word. Every one of those elegant structures is a finished product, the result of more than 10 billion years of assembly. And we are about to descend into layers of the sky where that assembly has not happened yet. So start the drop. Take one of the deep fields, pick a direction, and fall. The first billion light years go by and almost nothing changes. The galaxies here are our contemporaries, more or less. Their light only slightly stale. Spirals everywhere, familiar as pine trees. Pushed to 3 billion, 4 billion, 5 billion light years, which means 3, 4, 5 billion years into the past. And the changes begin. Subtle at first, like driving into a town where the architecture is just a little off. The spirals are getting scruffier, arms less combed, disks less settled. More of the galaxies are visibly interacting, tugging streams of stars off each other, colliding outright. Collisions happen in our era, too. But down here, they are becoming common. Because down here the universe is smaller. Remember, space has been expanding this whole time, which means in the past, everything sat closer together. The deeper we fall, the more crowded the room gets, and the more the galaxies behave like it. Keep falling. 7 billion years down. 8. Now the familiar catalogue is thinning out in a way you can feel. The grand, finished spirals are getting rare. The huge golden ellipticals, which in our era sit in the centers of galaxy clusters like retired emperors, are mostly missing, because those giants are built from mergers, and the mergers have not finished yet. What fills the frames instead is smaller stuff, bluer stuff. Galaxies that look half-assembled because they are half-assembled, and something else is draining out of the picture as we fall. Something you cannot see directly but that decides everything. The heavy elements are disappearing. Here is the thing about atoms that nobody tells you until you need it. The Big Bang made hydrogen, helium, and almost nothing else. Every other element in existence. The carbon in your body, the oxygen you are breathing, the iron in your blood, the silicon in the device you are watching this on. All of it was manufactured later, inside stars, and scattered when those stars died, which means the periodic table was never a fixed feature of the universe. It is an inventory that had to be built up, generation by generation of stars, like a savings account. Fall deep enough into the past and you are watching that account shrink towards zero. The galaxies down here are chemically poor. Their gas runs closer to raw hydrogen and helium. Their stars carry fewer metals. And that means the deep universe is missing more than pretty spiral arms. Rocky planets need silicon and iron and oxygen. Chemistry needs carbon. Down at these depths, the ingredients are scarce, because not enough stars have lived and died yet to fund the account. Feel what the descent is actually doing now. Because this is the real story of this chapter. Every layer we fall through removes something we take for granted. First, the tidy spiral architecture goes. Then the giant finished ellipticals go. Then the chemical inventory starts going. The elements themselves getting rarer. The universe simplifying beneath us, layer by layer. Like watching a city dismantled in reverse. Scaffolding reappearing. Walls coming down. Until you can see what the ground looked like before anyone built anything. Now hold the descent for a moment. There is something we have to do here. At roughly 10 billion years down. And I want you to remember this stop later. Because it is going to come back near the middle of this story and put a chill through everything. Freeze the frame on one galaxy. Any of them. A small, bright, ragged thing. 10 billion light years from Earth. Its light, 10 billion years old. We are seeing it as it was 10 billion years ago. Fine. You understand that now. But turn the arrangement around. 10 billion years have passed since this portrait was taken. That galaxy has presumably grown up, merged, settled, built its heavy elements, maybe grown quiet and golden. It has had every bit as much time as the Milky Way has had, which means it has had time to build stars and planets, and, for all anyone on Earth knows, astronomers. So ask it, if someone in that galaxy is pointing a telescope at our patch of sky at this very moment, what are they looking at? Think carefully before you assume the answer is us. Their sky obeys the same master rule ours does. Distance is delay. Whatever they see in our direction took time to arrive there. A lot of time. I am going to leave that question exactly where it is. Unanswered. Hanging over everything. We will come back for it. And when we do, it will turn this entire story inside out. For now, just keep it somewhere you can find it. Unfreeze the frame. Keep falling. 11 billion years down. 12. The galaxies are fragments now. Blue and violent and small. And the light is stretched so deep into the infrared that only an eye like Webb can catch it at all. We are approaching the layers where the word galaxy itself starts to lose its grip. Because the things down here are not really galaxies yet. They are what galaxies looked like before the universe taught them how. Every deep image we have been falling through was captured by some kind of eye. And it is worth pausing to appreciate that the layer we are entering now was, until very recently, beneath the bottom of every album humanity owned. Hubble's deep fields reached breathtakingly far. But even Hubble had a flaw. Its eyes worked mostly in visible light with a modest reach into the near-infrared. And you now know exactly what that means. At some depth, the expansion of space drags every galaxy's light below the range Hubble could catch. The galaxies beyond that depth were still out there, still shining, just singing below the bottom key of the instrument. For decades, the first billion years of cosmic history sat in our maps as an almost total blank. A basement level everyone knew existed and no one had ever lit. Then Webb opened its infrared eyes in 2022, and the basement lights came on. What Webb found down there surprised nearly everyone. And I want to be careful and honest about what the surprise was. It was not that the early universe turned out to be empty. Astronomers expected infant galaxies. And infant galaxies are what they got. The surprise was what those infants looked like and how fast they were growing. The deep frames came back crowded with small, fierce, brilliant objects. More of them, and brighter, earlier, than many models had predicted. Papers are still being argued over as you watch this. That is what a frontier looks like, while it is still a frontier. And I would rather show you the actual frontier than a tidied-up museum version of it. But here is the picture taking shape in those frames. And it is a picture worth standing in for a minute. Go down 12, 13 billion years, into the first billion years after the beginning, and the orderly cosmic city we started from is completely gone. Nothing down here is finished. Nothing down here is calm. What you see instead are clumps. Small, dense, ragged knots of stars, often only 100th or 1,000th the mass of the Milky Way, burning a furious blue-white because they are forging new stars at rates that make our modern galaxy look asleep. The Milky Way today produces a handful of new stars per year. Some of these little monsters are producing at many times that pace, while being a fraction of the size. Entire systems caught mid-explosion of construction, lit up like foundries running every shift at once. And they are never alone, because nothing down here is alone. The universe in this era is a fraction of its current size. Everything packed close, and the clumps live in each other's gravity. They collide constantly. They swallow each other. They tear streams of gas off their neighbors and blaze up with fresh star formation after every crash. Watching this era, you finally understand where the grown-up galaxies of our neighborhood actually came from. Nobody built the Milky Way in one piece. It was assembled out of things like these: crash by crash, merger by merger, over billions of years. The way a river is assembled out of creeks. This is why I keep steering us away from a certain kind of question. The record-chasing kind. Which single galaxy is the most distant ever confirmed? I could give you the current name. And the moment I did, this story would start aging. Because Webb keeps pushing the record deeper, and whatever holds the title when I say this may not hold it when you hear it. The record is a moving frontier. What matters, what will still be true years from now, is the question underneath the records. What did the universe look like before its galaxies had time to grow up? And the answer sitting in Webb's frames is this. It looked unfinished. It looked violent. It looked like a construction site the size of everything. One more detail, and it is my favorite in this whole chapter, because it connects the basement to your body. Those little foundry galaxies are building more than stars. They are building the inventory. Inside their furious blue stars, hydrogen is being fused into carbon, oxygen, nitrogen, silicon, iron. The first serious deposits into the account that was nearly empty one chapter ago. The biggest of those stars live fast, detonate, and blast their manufactured elements out into the surrounding gas, where the next generation of stars inherits them, builds on them, and detonates in turn. The periodic table is being funded in front of us. Some of the specific atoms in your left hand were forged in exactly this kind of place, in exactly this kind of era, 13 billion years before you borrowed them. So the basement is more than a curiosity. It is an origin, and you would be forgiven for thinking we have now arrived at the bottom of everything. Because what could possibly sit below the first galaxies? Something does, below the smallest, earliest clumps. The frames keep going down, and the objects get sparser and fainter, and then the count of galaxies drops towards zero. There is a layer down there with no galaxies in it at all, and below that, a layer with no stars. Because galaxies were never the first light. Before anything shaped like a galaxy existed, something else happened, spreading across the universe over its early ages, and it began in total darkness. The first stars had to turn on. We are going down to watch it happen. There is a number in this chapter that I need you to actually feel, because it changes what the whole sky means. Here it is. After the beginning of the universe, there were no stars anywhere, in any direction, for something like 100 million years, possibly longer. Say it plainly. The universe existed. Space and time and matter, all of it real, all of it running. And there was not one single star in the whole of it. No suns, no galaxies, no points of light of any kind. If you could have stood somewhere in that era and looked around, there would have been nothing to look at, in any direction. For as long as you cared to wait, the cosmos spent its entire childhood with the lights off. We are still falling, and the layer we have reached now is the era where that finally ended. And I want to tell it the way it deserves to be told. As an event, because it was one, maybe the biggest one between the beginning of everything and this morning. Set the scene. The universe down here is a few 100 million years old, small and dense compared to today, and it is filled nearly wall to wall with gas, hydrogen, mostly, with a share of helium, the raw stock left over from the beginning. The account of heavy elements stands at almost exactly zero. No carbon, no oxygen, no iron. Nothing has ever been built yet. So nothing has ever been scattered. The gas is not spread evenly, though, and that unevenness is the loaded gun. Some regions are a whisper denser than others, and in an expanding universe full of gravity. A whisper is enough. The denser spots pull a little harder. Pulling harder, they gather more gas. Gathering more, they pull harder still. It is the slowest avalanche in history, running for tens of millions of years. Invisible, silent, in the dark, and the entire future is riding on it. In the densest pockets, the collapsing hydrogen piles up and compresses. And compression means heat. The centers of the piles get warmer, then hot, then furious. The pressure and temperature climbing together as more gas rains down. And somewhere in the dark, in one of those pockets, the core finally crosses the threshold that matter has been waiting for since the beginning of time. Around 10 million degrees. The temperature where hydrogen nuclei slam together hard enough to fuse. Ignition. Somewhere out there in the black, with no one to see it. The first star in the history of the universe switches on, and then another one, in another pocket, and then thousands, then millions, all across the cosmos over the following stretch of millions of years. Dense pocket after dense pocket, crossing the threshold, the whole universe lighting up region by region like a city coming online after a blackout. The astronomers who study this era have a name for its ending. They call this turning point cosmic dawn. It is the most literal name in all of science. It was dawn, the first morning of everything. Now, about the stars themselves, because these were nothing like our sun. And the difference matters. Everything we know about how gas collapses suggests those first stars were monsters. With no heavy elements around to help the gas cool and fragment into small pieces, the collapsing clouds tended to stay in huge chunks. And huge chunks build huge stars. Many of the first generation are thought to have been tens or hundreds of times the mass of the sun, burning a blistering blue-white, blazing at temperatures and brightnesses our modern neighborhood almost never produces. And enormous stars pay for their brilliance with their lives. They burn through their fuel in just a few million years. A blink, and then they detonate. Those detonations were the second half of the event. The first monster stars exploded as supernovae, and inside them, and inside those explosions, the manufacturing finally began. Carbon, oxygen, silicon, iron, the first real deposits in the account, blasted out into the surrounding gas by the very deaths of the stars that forged them. The next generation of stars condensed out of that enriched gas, slightly seasoned now, and built more, and died, and scattered it. The chain that ends with the iron in your blood started here. In the deaths of giants no telescope has ever photographed. But there is one more thing the first lights did, and this one still stains the entire sky today. They did more than shine into the darkness. They attacked it. The universe of that era was filled with neutral hydrogen fog, atoms drifting cold and dark between the newborn stars, and the ferocious ultraviolet light pouring off those blue giants was energetic enough to smash the atoms it touched, ripping electrons off, ionizing the gas. Around every cluster of new stars, a bubble of ionized, transparent gas began to grow, eating outward into the fog. Bubbles from neighboring regions swelled, touched, merged, over hundreds of millions of years, bubble by bubble, region by region. The young stars and galaxies of the cosmic dawn burned the fog off the entire universe. Astronomers call it reionization, and its fingerprints are measurable. Right now, in the light from that era, starlight remodeled the whole cosmos, one growing bubble at a time. So here is the layer we have reached, the deepest layer with lights in it, the bottom of the album with pictures still on the page. Beneath the grown-up spirals, beneath the crashing foundry galaxies, there is this, the first fires, the first forges, and a war of light against fog that light won. You can feel the bottom coming now, and your instinct is telling you exactly what mine would say. Below the first stars there is obviously nothing left to see. Turn off the first lights and you must fall into pure, final blackness, the true flaw of everything. Your instinct is half right. The next layer down is dark, darker than anything we have crossed, darker than anything you have ever pictured. But empty turns out to be the wrong word for it, and flaw is even more wrong. Fall past the first stars, and you enter the layer that astronomers, who mostly name things with catalog numbers and Greek letters, chose to name like a ghost story. They call it the Cosmic Dark Ages. The name is exact. This is the stretch of cosmic history after the beginning and before the first star, spanning tens of millions of years at minimum, and, by most estimates, a lot more. And I want to actually take you into it, because almost nobody ever goes. Every documentary sprints past this era to get to the fireworks on either side of it. But our entire mission is to see, and this era is the strangest thing anyone could ever try to see. So stand in it with me. Put yourself there. You are floating somewhere in the universe during the Dark Ages. Look up. Nothing. Look left. Right. Down. Behind you. Nothing. There is not a single point of light in any direction. No matter how long you wait or how far you stare, no star exists yet to shine. No galaxy exists yet to glow. There is no distant spark. No faint cloud. Nothing at any depth, in any octave your eyes could ever hope to catch. This is a darkness the modern universe cannot produce anymore. Stand in the emptiest void between galaxy clusters today, and your sky still carries faint smudges. Distant light, arriving from somewhere. Here there is no somewhere. The darkness runs wall to wall and absolute, and it lasts tens of thousands of times longer than all of recorded human history. Your eyes are useless here. Every eye is useless here. Hold that thought, because it is about to matter more than it seems. Here is the strange part. The universe around you is full. You are floating in matter, everywhere. in every direction. The whole universe at this age is filled with hydrogen and helium gas, vast and cold and dark, thicker in some regions, thinner in others. Nothing about the cosmos is missing. The raw material for everything you have ever seen is already here. The primordial gas that stars will one day forge into carbon and iron and oceans and worlds. Every particle of it present and drifting in the black, waiting for its first furnace. The universe is loaded. It just has not fired yet. And it is anything but idle. That is the biggest misconception you could carry into this place. That the Dark Ages were a pause. Dead time. The universe waiting around. The truth runs the other way. This darkness is one of the busiest construction sites in cosmic history. You just cannot see the work, because the work is being done by something that does not shine. All through the black, gravity is pulling. The slightly denser regions of gas are gathering. Exactly the slow avalanche we watched in the last chapter. But this is where it actually started. Millions of years earlier, in total darkness, and the gas is only half the workforce. Threaded through the entire universe is a second kind of matter. Invisible. 5 times more abundant than everything we are made of. Dark matter. It gives off no light in any octave, which in this era makes it no different from everything else. And its gravity is quietly assembling the framework of the future, pulling itself into knots and filaments, a scaffolding of pure mass spanning the whole cosmos, with the hydrogen slowly draining down into its grip. Every galaxy that will ever exist is being staked out right now, in the dark, as a knot in that invisible scaffold. The Milky Way's foundation was laid here, in this blackness, before there was a single light anywhere to lay it by. When the first stars finally ignite at the end of this era, they will not ignite in random places. They will ignite exactly where the Dark Ages put the pilings. So this is the layer beneath the first lights. Calling it a floor gets it completely backward. It is a workshop with the lights off. The size of everything, running for millions of years, silently framing the entire future. Now, bring your telescope back into the picture, because here is where our mission slams into what feels like the end of the road. Everything we have seen tonight, every layer, we saw because something down there shone. Grown spirals shine, foundry galaxies shine, first stars shine, but the Dark Ages, almost by definition, hold nothing that shines. No stars, no galaxies, and the ambient light of the era does not come packaged in a form our deep field cameras can simply photograph like a galaxy. From here, looking down past the cosmic dawn means looking into layers with no lamps in them. So we have finally hit it. Right, the bottom of seeing. The last page of the album is the first starlight. And below that, the pages are simply black. And the honest answer to our whole question is that the edge of the observable universe looks like nothing at all. That is the reasonable conclusion. It is what almost anyone would sign off on. We went looking for the darkest place in the universe, the deepest, oldest, blackest layer of the sky, below the last star, below every light that ever turned on, and instead, right below the darkness, the entire sky catches fire. Back in Chapter 3, we made a rule, and I told you we would need it again and again. Every time the sky goes dark, do not trust the darkness. Change your eyes. We are floating at the bottom of the album, staring into the cosmic Dark Ages. And every instrument we have used tonight has gone blind. Optical eyes see nothing down here. Even Webb's magnificent infrared eyes are reaching their floor, because we are running out of starlight to stretch. There are no stars below this layer. It feels like the end. So do the drill. Do not trust the darkness. Ask the question we asked at every layer above this one. Is the sky in this direction actually empty? Or is it singing below the bottom key of our instrument? Build a new eye. Forget visible light. That octave died billions of light years ago. Forget infrared. We have pushed that one to its limit. Go lower. Build an eye for microwaves. The octave far below anything a living creature has ever seen, with wavelengths measured in millimeters. The territory of radar dishes and kitchen appliances. Cool it down. Point it at the deepest, blackest, most certified empty patch of sky we can find. The layer below the first star that ever ignited. Turn it on. The sky explodes. There is no gentler way to say what happened, because this is what actually happens. The blackness does not reveal a faint dot here and a smudge there, the way Hubble's empty patch did. The entire sky lights up at once. Every direction, every square degree, north, south, straight up from both poles, behind every star, behind every galaxy, behind every dark gap between the galaxies. The whole celestial sphere is glowing in microwaves, wall to wall, with no gaps, no shadows. End. It is one continuous surface of light, wrapped around the entire sky, everywhere we have ever pointed a microwave eye since the day we built one. Sit with how strange that is for a second. Every other thing we have found tonight was a thing. A galaxy here, a cluster there, objects with edges, scattered across black space. This is different in kind. This has no edges because it covers everything. You cannot point a microwave eye anywhere in the sky, anywhere at all, without hitting it. Behind the last galaxy, in the deepest layer of every deep field, in the middle of every void, it is there, the same glow, at almost exactly the same temperature, in every direction humanity has ever looked. And it is old. That is the part that should raise the hair on your arms. Remember the master rule. Depth is time. This glow sits below the first stars in every direction. Deeper than the oldest galaxy. Deeper than the cosmic dawn. Deeper than the dark ages themselves. Whatever this light is, it was already in flight before the first star in the universe ever switched on. It is, by a wide margin, the oldest light that has ever been or will ever be photographed. Nothing in the sky sits behind it. Here is what it is. Follow the logic down, because you already own every piece of it. The universe is expanding, which means it used to be smaller. Smaller means denser, and denser means hotter. And if you run the film backward far enough, you reach an era when the entire universe, every cubic inch of it, was as hot as the surface of a star. A universe that was hot, everywhere, wall to wall, a single continuous glowing furnace with no dark anywhere in it. Because there was no empty space to be dark. A furnace like that is full of light, blinding quantities of it, everywhere, in every direction. And when that era ended, the light was not destroyed. Light does not simply vanish. It was released into the newly opened sky, from every point, in every direction, and it has been flying ever since. Some of it, after 13.8 billion years in flight, is arriving here, now, tonight, from every direction, because it was released from every direction, because it came from everywhere. That is the glow. It is the leftover light of the era when the whole universe was a furnace. The afterglow of the beginning itself. Still arriving, 13.8 billion years late. And you know exactly why it arrives as microwaves instead of a blinding white sky. You learned the mechanism 6 chapters ago. The light launched as brilliant visible glow, from gas about as hot as the surface of a star. But it has spent 13.8 billion years crossing an expanding universe. An expansion stretches light. This light has been stretched further than any light in existence, by a factor of about 1100. Dragged down the entire keyboard, out of the visible octave, through the infrared, all the way into microwaves. The brightest light in the history of everything arrives at your rooftop as a whisper, about 2.7 degrees above absolute zero. Too long and too faint for any living eye. The sky has been on fire your entire life, in a color you do not own. Astronomers call it the cosmic microwave background, and we are going to spend the next stretch of this journey learning to read it, because it is far more than a blank glow. There are patterns frozen in it, and those patterns are the oldest information in existence. But before any of that, you deserve the answer to the question you should be asking right now. If this glow covers the entire sky, and it has been arriving forever, why did nobody notice it? For most of human history, how do you miss a wall of light wrapped around everything? Easy. You miss it because it whispers in an octave nobody owned. To hear it, someone first had to imagine it. Someone had to sit down, years before the technology existed, with nothing but a pencil and the physics of a hot, young universe, and calculate that this exact glow had to be out there, at almost this exact temperature, filling the entire sky. Someone did. In 1948, and then the world forgot him. The story of the oldest light in the universe starts with no telescope anywhere in sight. It starts with a graduate student who needed a thesis topic, and an advisor who treated the entire cosmos like a physics homework problem. The advisor was George Gamow, and he was one of the great characters of 20th century science. Ukrainian-born, educated in the Soviet Union, he had escaped Stalin's grip in the early 1930s, and by the 1940s he was in Washington, at George Washington University, entertaining an idea that most serious physicists considered somewhere between fringe and embarrassing. The idea that the universe had a beginning, a hot one. Understand the room Gamow was standing in. In 1948, the expanding universe was accepted. The measurements were solid. Everyone agreed the galaxies were flying apart. But the conclusion hiding inside those measurements, that everything was once compressed into a hot, dense state, that the universe had a birthday, struck many scientists as too strange, too convenient, almost theological. The rival picture, an eternal universe with no beginning, was considered the respectable position. The whole hot beginning idea did not even have a serious name yet. The name it eventually got, Big Bang, started as a dismissive jab by a rival astronomer on the radio. Gamow did not care about respectable. He cared about a specific physics puzzle. Where did the chemical elements come from? And he handed the heart of that puzzle to his doctoral student, a young man named Ralph Alpha, with a suggestion that was almost reckless in its ambition. Take the hot beginning seriously. Treat the infant universe as an actual physical furnace, with real temperatures and real densities, and calculate what such a furnace would actually cook. Alpha was nobody famous. He was the son of Jewish immigrants, a kid from Washington who had worked his way through night school while holding day jobs, doing his physics degree in the evenings for years. What he had was exactly what the problem needed. ferocious skill in calculation, and the stamina to grind through it. Alpha worked the numbers of the primordial furnace and got the recipe of the early universe. Hydrogen and helium in proportions that matched what astronomers actually measured in the sky. The infant furnace was more than a fantasy. It made testable predictions. And the first big one checked out. Then came the step that concerns us. The one that belongs in this story forever. Later that same year, 1948, Alpha and a colleague named Robert Herman pushed the logic one step further. And the step was beautifully simple. If the whole universe was once a glowing furnace, that furnace light could never have been destroyed. It must still be here, filling the universe, stretched and cooled by billions of years of expansion. And a stretched, cooled furnace glow is more than a poetic idea. It is a number you can calculate. So they calculated it. The leftover light, they wrote, should today have a temperature of about 5 degrees above absolute zero, which would put it in the microwave part of the keyboard, coming from every direction in the sky. Hold that up against what you now know. The measured temperature of the cosmic microwave background is about 2.7 degrees. Alpha and Herman, in 1948, with pencils, with no microwave astronomy in existence, working from nothing but the physics of a hot beginning, called the glow that covers the entire sky and landed within a factor of 2 of its temperature, 17 years before anyone would see it. Here is what happened next. Almost nothing. The prediction landed in a scientific world that was not listening. The hot beginning was unfashionable. Microwave technology capable of the measurement barely existed, and the few people who had the equipment did not know about the prediction. And the people with the prediction could not get anyone with equipment interested. Alpha and Herman spent years giving talks, publishing refinements, pointing at the sky and telling anyone who would listen that the birth certificate of the universe was sitting up there, humming in microwaves, waiting for an antenna. The community shrugged. The papers gathered dust. The 2 men eventually moved on. Alpha into industrial research. His greatest predictions sliding quietly out of the scientific conversation. 17 years later, in 1965, the glow was found by accident, by radio engineers who were not looking for it, who did not know Alpha's name, and who spent months trying to make the signal go away because they assumed it was a flaw in their antenna. The story of that accidental discovery is famous. This channel has told it before, and it ends with a Nobel Prize. The prize went to the men with the antenna. Ralph Alpha's name was missing from it. He lived until 2007, long enough to watch satellites map his glow across the entire sky in exquisite detail, long enough to see the temperature he had estimated with a pencil pinned down to extraordinary precision. A fraction of 1,000th of a degree, long enough to receive, in his final years, the National Medal of Science, an apology in the shape of an award. The man had aimed a calculation at the beginning of time and hit it. And he spent most of his life watching the world forget he had fired. I am telling you his story for a reason that goes beyond fairness. It is the reason we can trust everything ahead of us. The cosmic microwave background was never stumbled upon and then explained after the fact by whoever got there first with a story. It was predicted, called in advance, from theory, temperature and all, by people who had never seen it. When a scientific idea tells you what you will find before you look, and you look, and it is there, that idea has earned a different level of trust. The hot beginning earned it. The glow was the receipt. So now we hold the receipt, a wall of ancient light, wrapped around the entire sky, predicted on paper in 1948. found in 1965, mapped ever since. Which brings us to the map itself. Because when the satellites finally photographed Alpha's glow in full detail, edge to edge across the whole sky, they found it was anything but a smooth, featureless hum. There are patterns in it, faint blotches, slightly warmer here, slightly cooler there, frozen into the oldest light in existence. Those blotches are the most valuable pixels humanity has ever captured. They are a photograph of the universe as a newborn, and hiding inside them is the answer to what the furnace actually was, and what happened on the day the fog finally broke. It is time to learn how to read the oldest picture anyone will ever take. In the early 1990s, a satellite called COBE photographed Alpha's glow across the entire sky for the first time. 2 more satellites followed. WMAP in the 2000s, then Planck in the 2010s, each one sharpening the picture further. And what they produced is an image you have probably seen without knowing what you were looking at. An oval map, speckled with blue and orange blotches, like static on an old television that someone colorized. It hangs in physics departments all over the world. That oval is the whole sky, unwrapped and flattened, photographed in microwaves. It is a picture of the entire universe at 380,000 years old, and I want to teach you to read it. Because almost everything we know about where we came from is written in those blotches. First, what the colors mean. The glow of the cosmic microwave background is astonishingly smooth. Measure its temperature in any direction, and you get 2.725 degrees above absolute zero. And the same in the opposite direction. And the same everywhere, matching to better than 1 part in 10,000. The blue and orange blotches on the map are the tiny exceptions. Spots where the temperature runs a few millionths of a degree warmer or cooler than average. Millionths. The blotches have been color-enhanced within an inch of their lives, just so human eyes can see them at all. The real glow is smoother than the surface of a billiard ball. Those millionths are the treasure. Here is why. A warmer or cooler spot in the glow marks a place where the primordial furnace was a whisper, denser or thinner than average. And you already know, from the Dark Ages, what a whisper of extra density becomes when gravity gets millions of years to work on it. It becomes an avalanche. The denser spots in that baby picture pulled harder, gathered more, and grew up to become the knots and filaments of the cosmic web, the galaxy clusters, the Milky Way, this planet, you. The cooler, thinner spots grew up to become the great voids. That speckled oval is more than a photograph of the infant universe. It is a seating chart for everything that came later. Astronomers can take the pattern of those blotches, run the physics forward 13.8 billion years inside a computer, and out comes a universe with the same statistical architecture of webs and voids that our telescopes actually see. The baby picture predicts the adult. That agreement, checked and rechecked for 3 decades, is one of the main reasons cosmology gets to call itself a precision science. Now for the misconception, because there is a big one, and clearing it up is the last piece of preparation we need before this story turns inside out. When you hear that a wall of ancient light surrounds the entire sky, your brain builds a picture, a shell, a glowing sphere out there at the rim of everything, with us floating in the middle, like the painted inside of a dome. It feels like the CMB must be a physical surface hanging at the edge of space. And if you flew far enough, you would eventually pull up alongside it and touch it. Here is the picture that is actually right. And it starts with the fact your intuition keeps sliding off. The furnace was everywhere, 380,000 years after the beginning. Every point in the entire universe was glowing hot gas. The point where the Milky Way now stands was furnace. The point 46 billion light-years away was furnace. Everywhere was furnace. And when the glow was released, it was released from every point, in every direction. Every location in the universe fired light toward every other location. So, what determines the glowing wall we photograph? Simple. Travel time. Tonight. The light arriving at Earth from that era is precisely the light that left from points whose distance equals 13.8 billion years of flight. Adjusted for expansion. Light from nearer points of the old furnace swept past Earth ages ago and is gone downstream. Light from farther points has yet to arrive and is still inbound. What we photograph as a wall is just tonight's shell of arrivals. The set of all points whose furnace light is landing on us today. Try this picture instead. You are standing in a room where every wall, the floor, the ceiling, every surface in every direction, is a photograph of the past. Wherever you turn, the room shows you the same ancient morning, but the walls are made of arriving light, refreshed every second by mail from slightly farther away. Tomorrow, the light landing on Earth will come from points slightly deeper out. So the wall we photograph tomorrow sits fractionally farther away than the wall we photograph today. The room grows, the photograph stays. A surface like that has a proper name in physics, and the name gives the game away. It is called the surface of last scattering, and listen to what kind of thing that name describes. It marks the last moment the light touched matter. A moment. The CMB is a moment in time, visible in every direction. Because the moment happened everywhere, it only wears the costume of a surface in space, which means something wonderful and slightly dizzy. An astronomer in a galaxy 10 billion light-years from here, running the same instruments, also photographs a wall of ancient light wrapped around their entire sky. The same furnace, the same morning, the same 2.7-degree whisper, but their wall is built from a different shell of arrivals. Light launched from different points of the old furnace. The set of points whose mail is landing on them tonight. Same past, different room. Hold on to that, because you have now heard me say, in 3 different ways, that these walls are made of arriving light rather than standing stone, and there is exactly one honest way left to prove it. Back in Chapter 5, 10 billion light-years down, we froze the frame on a small, ragged galaxy and asked a question I refused to answer. If someone in that galaxy is looking at us right now, what do they see? I told you the answer would turn this story inside out. The debt comes due now. We are done looking at the edge from here. We are going there. Physics does not allow what we are about to do. No ship does this. No signal does this. Nothing ever built or born does this. But imagination has no speed limit. And we have earned this trip. So here is the one miracle of this entire story. And we are spending it now. Pull up the deepest map we own. Find the most distant region humanity has ever detected. Out at the very rim of the observable universe. The place our charts mark as 46 billion light-years away. Lock the coordinates and teleport instantly to that exact location as it exists right now, tonight, in the present tense of the universe. Keep that phrase in mind, because it is the whole trick. No light, no signal, no telescope could ever show us this place as it is tonight. Only the miracle can. That is exactly why we bought it. You arrive. You open your eyes. Give yourself the full 60 seconds before any instruments, Because the first minute is the whole lesson. You are floating in space, and around you is a night sky. Stars. Sharp. Steady. Quiet points of light. Scattered across the black in patterns you have never seen. No shape up there matches anything from home. There is no Big Dipper. No Orion. And the bright band of the Milky Way is missing. But the grammar of the sky is perfectly familiar. Stars in their colors. White and gold and red. Soft smudges between them that your gut correctly reads as galaxies. Darkness in the gaps. If you woke up here with no memory of the trip, you would never gasp. You would think you were home, under someone else's constellations. Now do the tourist thing. Look for the attraction. You are standing at the edge of the observable universe, the most extreme address on every map our species has ever drawn. So find the edge. Look for the wall, the boundary, the glow, the place where the stars stop, the sign that says the universe ends here. Take all the time you want. There is nothing of the kind. In every direction the sky runs on. Stars and galaxies and black gaps. The same cosmic scenery at roughly the same density. No thinning. No ream. No sem. The deep sky here looks like the deep sky anywhere. This is a Tuesday night in an ordinary neighborhood of the universe. And the fact that a small blue planet 46 billion light-years away has drawn a line through this exact spot on its maps has left no mark here whatsoever. Nothing ends here, because our maps were never measuring where things end. They were measuring where our mail runs out. You have not traveled to an edge. You have traveled to the far end of a delivery route. But you have not felt the real shock yet. The real shock is waiting in what this place cannot see. Turn around. Face back the way you came. Somewhere in that direction, 46 billion light-years off, is everything you have ever known. The sun, the earth, every person alive. Find it. You have every eye humanity has ever built. Use them all. Start with your own eyes. Nothing, obviously. Just stars and dark. Raise an optical telescope, the finest ever made, and sweep the coordinates. Nothing. No Milky Way. No smudge. No dot. No single pixel. Switch eyes. Go to infrared. The octave that resurrected the ancient galaxies for Webb. Sweep again. Deep fields. Long exposures. Everything. Galaxies everywhere. Thousands of them. And none of them is ours. The direction of home contains no trace of home at any wavelength starlight can occupy. And you know why. You have known since Chapter 2. Distance is delay. The Milky Way's starlight has been flying toward this place for billions of years. But the gap is too vast, and expansion keeps swelling it. The light of our galaxy as it looks tonight has never arrived here. It will never arrive here. From this address, the modern Milky Way, the sun, the earth, the entire living present of everything you love, is simply unarrived. It appears nowhere in this sky at all. So is home just missing here, erased reach for the last eye on the shelf. The microwave eye, the one that sees the oldest octave there is. Point it at the coordinates of Earth and turn it on. There, glow, right at the coordinates where home should be. The detector fills with light. It is smooth. Ancien. 2.7 degrees above absolute zero. Part of an unbroken wall of glow that wraps around this entire sky. Exactly like the wall that wraps around ours. It is their cosmic microwave background, and sitting in it, at the precise position of everything we know, is a patch of orange speckled furnace light. released 13.8 billion years ago. Still arriving here tonight. Understand what you are looking at, because this is the sentence this whole journey has been climbing toward. That patch of ancient glowing plasma is us. It is the exact region of the primordial furnace that would later cool and collapse and ignite its first stars and assemble the Milky Way and build the sun and grow the earth. Their telescopes photograph that patch every night. To them, it is a few pixels in their baby picture of the universe, a faint warm blotch in their oldest light. That blotch is our home address. Photographed 13.8 billion years before we moved in. We are the edge of their observable universe. We are their CMB. And now the mirror swings both ways, and the whole night snaps into place. All journey long, we have been looking out at the rim of our maps, at that wall of ancient light, thinking of it as the far frontier, the deep elsewhere, the strange glowing bottom of the sky. Stand here, and the truth is symmetrical. The blotches in their sky are the ordinary neighborhoods of our universe, including ours. Seen too early. The blotches in our sky are the ordinary neighborhoods of theirs. Seen too early. Right now. In the deep fields taped to our observatory walls. At the rim of our own baby picture, there are warm patches of furnace glow that have long since grown up into calm adult galaxies with quiet Tuesday skies. Places exactly like this one. Places that might have telescopes of their own, pointed back along the line, photographing a warm orange blotch, and never suspecting the blotch is watching them back. Nobody stands at the edge of the universe. The edge is a view. Every observer everywhere is wrapped in their own wall of ancient light, their own private rim of unarrived mail. And every one of those walls is made of other people's home addresses. The edge of the observable universe is a place no one can visit, because you are standing at the center of one right now, and you are pixels at the edge of someone else's. If that just rearranged the sky for you the way it once rearranged it for me. The like button is down there, and subscribing means you will be here for the nights, like this one still to come, because the trip is far from over. We are still standing 46 billion light-years from home, and there is a question hanging in this strange sky that we have not dared to ask yet. If this place has its own wall of ancient light, its own observable universe, then their maps must reach into regions of the cosmos that no instrument on Earth has ever detected. Regions that, from our address, have never existed in any measurable way at all. It is time to talk about what their sky knows that ours never can. We are still out here, 46 billion light-years from Earth, standing under a stranger's sky. Before we go home, there is one piece of surveying left to do, and it is the piece that finishes what the last chapter started. We know this place has its own wall of ancient light. Now let's find out what that actually costs us. Their wall works exactly like ours. It is a shell of arrivals, the set of all points whose furnace light is landing here tonight. And it sits at the same distance in every direction, because the physics here is the physics everywhere. So their observable universe is a sphere, the same size as ours, roughly 46 billion light-years in radius, centered on them. Ours is centered on us, and the centers sit 46 billion light-years apart. Picture the two spheres together, because the geometry does something to you once you actually see it. Two enormous bubbles of the knowable, overlapping through the middle like two circles in a diagram. The overlap zone is huge, and it contains both of us. It holds all the galaxies that both civilizations can, in principle, photograph. Their deep fields and our deep fields share those galaxies. Portraits of the same objects taken from different seats, at different ages, in different octaves of stretch. Everything this journey has descended through tonight. The grown spirals, the foundry galaxies, the first lights. All of it lives in territory our two skies hold in common. But the overlap is only half the story. The other half lives in the two slivers that never touch. On the far side of their sphere, the side facing away from Earth, their observable universe reaches tens of billions of light years past the rim of ours. And that whole region is full of galaxies their astronomers can photograph on any working night. Galaxies with positions in their catalogues, redshifts in their tables, portraits in their archives. Ordinary galaxies, as real as Andromeda, and from Earth, the entire region is silence. No photon from any of those galaxies has ever landed on our planet. Not one. In 13.8 billion years. An expansion guarantees the streak continues. Those galaxies are missing from our sky in the deepest sense available. By every measurement our species can ever perform. From our address, that entire wing of the cosmos has never existed. And the mirror image sits behind us. Our sphere reaches tens of billions of light years past the rim of theirs. Into a sliver crowded with galaxies we have photographed, catalogued, and named, some of them sitting in the deep fields we walked through hours ago. From this sky, where we are standing right now, every one of them is silence. No picture, no glow, no evidence. Two archives of wonders, each packed with marvels the other can never confirm are real. Now run the move again, because there is no reason to stop at two. Teleport to a galaxy on the far rim of their sphere, and a third bubble of the knowable draws itself around that new address, reaching into territory the first two skies never touched. Hop again. Another bubble. Every galaxy in existence. Hundreds of billions of them by the most conservative counts. By some estimates, as many as 2 trillion in our sphere alone. Sits at the exact center of its own observable universe, wearing its own wall of ancient light, holding its own archive that no other address can fully share. The universe was never one map with one edge. It is an ocean of overlapping maps, and every map is centered on whoever is holding it, which finally explains something that bothered you at the start of this journey, whether you noticed or not. Every diagram of the observable universe puts Earth at the dead center. That used to look like arrogance. The same old mistake our species made with the sun and the planets. Humanity, crowning itself the middle of everything again. Now you can see it is the opposite. We sit at the center of our observable universe for the same reason you sit at the center of what you can see from your own eyes. It is a limitation wearing the costume of a throne. Every observer gets the same centered sky, which means the centering carries no information and grants no status. The dead center of the observable universe is simply where the observer keeps their telescope. That leaves one question, and I can hear it forming. So let's handle it the way the evidence handles it, which is quickly. If every observer owns a private sphere, and the spheres tile outward in every direction, then how big is the whole thing, the entire universe? All the maps combined, the full territory. Here is the honest state of human knowledge. There is one real handle on that question, and it is geometry. If space itself has an overall curvature, the way Earth's surface does, then a large enough universe could close back on itself and have a finite total size. That curvature is measurable. It leaves fingerprints in the sizes of the blotches on the baby picture. and the satellites have measured those blotches about as precisely as this era of instruments allows. The verdict came back flat. No curvature detected. To the precision of everything we own. And here is what flat honestly buys us. It tells us the whole universe must be enormously larger than the piece we can see. What it refuses to tell us is the total size. The universe could be finite and unimaginably vast. Its curve hiding below our instruments, the way a backyard reads as level ground on a planet 8,000 miles wide. Or it could simply go on without end. The measurements set a floor and stay silent about the ceiling. Nobody knows. And any voice telling you otherwise has left the measurements behind. That is the whole answer. And we are going to leave it exactly that size. This journey deals in what can be seen. And past this line, nothing can be. So, let's go home. Snap back across 46 billion light years, back under the familiar constellations, back to the planet where all our telescopes live, because standing at the rim taught us what the edge is. A view, a private horizon of arrivals. One per observer. No walls anywhere. But it also sharpened the one question we have been circling all night without ever asking straight. Our view has a bottom. The baby picture. The wall of ancient light at 380,000 years old. Fine. But why there? Why does the album stop at that page? The universe existed before that moment. There were 380,000 years of history running before the first page of our album. Light existed during those years. Enormous quantities of it. So, where are those photographs? Why can no eye we will ever build? In any octave. See 1 minute past that wall. Because the wall was never made of distance. It is made of fog. And it is time you saw the inside of it. Every limit we have hit tonight has fallen to the same trick. The sky goes dark. We change our eyes. The sky fills back up. Optical went blind. Infrared saw. Infrared went blind. Microwave saw. The trick has worked every single time. And by now you trust it. Which is exactly why this chapter is going to feel like a betrayal. Because the trick is about to fail. Permanently. And the reason it fails is the single most important fact in this whole story. Here is the plan any reasonable engineer would draw up. The baby picture shows the universe at 380,000 years old. We want to see earlier. So build a better eye. More sensitive. Bigger. Colder. Tuned to whatever octave the even older light has been stretched into. Catch the photographs from year 100,000. From year 1000. From the first afternoon. Just keep doing what we have done all night. The plan fails. And it fails for a reason that has nothing to do with engineering. There are no photographs from those years. None were ever mailed. To see why. We have to do the one thing left that we have not done. We have to go inside the wall. So take the miracle out one last time. Teleport backward. Into the era before the baby picture. Into the universe at, say, 100,000 years old. Open your eyes. You are standing inside light. That is the only honest description. In every direction, wall to wall, the sky is a uniform blinding glow. Orange-white, brighter than staring into a furnace. And it has no features at all. No stars. Obviously. None exist. But also no shapes. No bright patches. No dim patches. No direction that looks different from any other direction. Above. Below. Left. Right. The identical searing glow. And here is the strangest absence of all. You have no shadow. Nothing here has a shadow, because shadows need light that comes from somewhere. And this light comes from everywhere. You are floating inside a glow with no source, no edge, and no view. Visibility in this universe is essentially zero. You are standing in the best lit place that has ever existed, and you cannot see. Now shrink down and look at why. Because the mechanism is the key to everything. The universe at this age is filled with plasma. That word just means the gas is so hot that its atoms have come apart. Electron, which, in your body, sit bound inside atoms, are here torn loose, free, swarming everywhere. And free electrons do something vicious to light. They scatter it. A photon in this era gets to fly for only a tiny stretch before it slams into a free electron and ricochets off in some random new direction. Then it flies another tiny stretch and hits another electron. Ricochet. Another. Ricochet. Every photon in the universe is trapped in an endless pinball game, bouncing billions upon billions of times, going nowhere. Light exists here in staggering quantities. More photons per cubic inch than the modern universe will ever see again. And every single one of those photons is a prisoner. That is what a fog is. That is all a fog ever is. The droplets in a morning fog on Earth do the same thing to sunlight, scattering it a few feet from your face, wrapping you in a glowing grey blur. The early universe was a fog of free electrons, filling all of existence, with no outside to escape to. And here is the sentence that kills the engineer's plan. A photograph is made of light that traveled in a straight line from its subject to your eye. In a universe where no light travels in a straight line, photographs are physically impossible. The information never leaves the room. So understand the limit we have hit, because it is a different species of limit from everything before it. The problem was never that our telescopes are too weak. The problem is that the universe itself, for its first 380,000 years, was opaque. A telescope 1,000 times more powerful than Webb changes nothing. A telescope 1 billion times more powerful changes nothing. You cannot photograph mail that was never sent. And the foggy universe never sent any. One more thing before we leave. And I want you to have it because almost nobody gets told this. The fog had a voice. The plasma filling this universe is a fluid, a continuous ocean of matter and trapped light. And it is being squeezed. Gravity pulls the denser regions inward. The trapped light pushes back outward. Pull. Push. Pull. Push. And an ocean caught between a pull and a push does what every ocean does. It oscillates. Pressure waves, rolling through the plasma of the entire universe. Compressions and rarefactions on a scale of tens of thousands of light years. There is a technical name for a pressure wave moving through a fluid. It is called sound. The early universe was ringing. The fog you are standing in hums with the deepest note that has ever existed. Sound waves the size of future galaxy clusters rolling through everything. And those waves left fingerprints, the warm and cool blotches on the baby picture trace. In part, the crests of those very sound waves, frozen mid-vibration, when cosmologists study the CMB. Part of what they are doing, in the most literal sense available, is reading the recorded sound of the beginning. Now watch the ending, because you already know it, and it is still the best scene in the story. The universe expands. Expanding, it cools. For 380,000 years, the fog holds. The pinball game runs. The great note rings. And then the temperature falls through a threshold, around 3,000 degrees. And everywhere in the universe, over a stretch of time brief by cosmic standards. The free electrons slow down enough to be captured. Nuclei grab them. Atoms form, stable and neutral, all across existence. And the pinball game simply runs out of bumpers. Every photon in the universe, mid-flight between collisions, suddenly finds nothing in its path. The last scattering has happened. The fog does not burn off from some edge inward. There is no edge. It clears throughout the whole universe together, and the light of the furnace is released from every point, in every direction, free. Some of it has been flying ever since. 13.8 billion years. Stretched 1100-fold. Faded to a 2.7-degree whisper. Tonight a little of it ends its flight in our detectors, and we call it the cosmic microwave background. And now you know exactly what it is. It is the fog's last touch, the final ricochet. Delivered. That is why the album has a first page. The wall in our sky is the moment the universe became transparent, seen from inside. Forever. Nothing before it can ever be photographed with light, because before it, light could not fly. So the pattern that carried us all night is dead. We cannot change eyes our way past this wall, because behind it there is no light in any octave to catch. Straight lines simply did not exist yet. Unless, and hold this thought as we head into the final act of this story, unless light was never the only messenger, unless something else was in that fog with us, something the free electrons could never touch, something that flew straight through the pinball game as if it were not there, carrying mail from the other side. Physics says two such messengers exist, and humanity has already caught one of them. Those two messengers are coming. I promise. But before we chase the last mail in the universe, we have earned a moment. I have been saving all night, because without quite announcing it, you and I have built something over the last few hours. And I want you to see the whole thing assembled before we take the final step. We have built 4 skies, and they all hang in the same direction. Here is what I mean. Go outside tonight, wherever you live, and pick one patch of sky, any patch. But let's use the famous one, the little square near the handle of the Big Dipper where Bob Williams once spent 10 days of the world's telescope. Hold your fist at arm's length and you have covered it. One patch, one direction. Now watch what happens to that single piece of sky as we swap through every eye humanity owns, one at a time. The full inventory of vision. In order. Eye number 1, the ones you were born with. Look at the patch. It is black. Maybe 1 or 2 faint stars if your night is dark and your eyes are young. Foreground stars. Local stuff. Porch lights of our own galaxy sitting a few dozen light years out. The unaided eye does have one long-distance trophy. And you met it in Chapter 2. That faint grey smudge of Andromeda. 2.5 million light-years off. But that is one smudge in one corner of the sky. An exception you need a perfect night to catch. Point your bare eyes at this patch. At almost any patch. And what you get is the local neighborhood of our own galaxy. A few thousand light-years of stars, floating on a black that looks bottomless to the naked eye. The deep universe simply is not there. Every ancestor you have ever had looked at that same patch and saw that same nothing. The savannah eye reports an empty universe with a thin sprinkle of lights. And the savannah eye is wrong. Eye number 2. The optical telescope. Same patch. Same night. Now the black cracks open. Galaxies appear. Dozens. Then hundreds. Then thousands. As the exposures deepen, spirals and ellipticals stacked from millions to billions of light-years down. This is Williams 3000. The crowd hiding behind the dark. The patch was never a void. It is a hallway, and the hallway is packed. But the optical eye has a flaw, somewhere around 10 billion years down. Its galaxies redden, fade, and slide below the bottom of the instrument. To the optical eye, the hallway ends in darkness, and the optical eye is wrong. Eye number 3, the infrared eye. Same patch. The darkness at the bottom of the hallway ignites. The stretched light of the first billion years snaps into view. The small, fierce foundry galaxies. The construction sites. The infancy of everything. Layers that no optical mirror could ever catch because expansion had dragged them out of the octave. The hallway turns out to be deeper than the optical eye could ever know. But the infrared eye has a flaw too. Below the first stars, there is nothing left for it. Because below the first stars, nothing shone in its range. To the infrared eye, the hallway ends in a final black basement, and the infrared eye is wrong. Eye number 4, the microwave eye. Same patch. The basement is on fire, wall to wall, edge to edge. The entire patch glows. The stretched furnace light of the beginning itself. 2.7 degrees. Speckled with the blotches of the baby picture. The bottom of the hallway was never dark. It is the brightest thing that ever happened. Arriving 1100 times stretched. Whispering in a register no living thing has ever seen. 4 eyes. 4 completely different universes. An empty void. A crowded hallway of galaxies. A construction site at the dawn of time. A wall of primordial fire. And here is the point of the whole exercise. Nothing in the sky changed between those 4 pictures. Not one photon out there rearranged itself. The only thing that changed, each time, was the eye. Same sky. Same direction. 4 different universes, depending entirely on the instrument doing the looking. Let that reorganize something in your head, because it reorganized all of astronomy. We spent this whole journey asking where the edge of the observable universe is, treating it like geography, a distant address, a place out past the last galaxy. But look at what we just did. We stood in one spot, faced one direction, and moved the edge 4 times without taking a step. For the naked eye, the readable sky runs out a few thousand light years deep, with one faint exception. For the optical eye, 10 billion. For the infrared eye, 13 billion and change. For the microwave eye, the wall of first light itself, the edge never was a place out there. The edge hangs at a wavelength. It lives in the receiver, in the mirror, in the eye. Now, one clean distinction, so nobody can accuse us of sloppy bookkeeping. The true horizon, the causal one, the boundary of everything whose light has had time to arrive, sits where physics put it, and no instrument moves it an inch. What each new eye changes is how much of that delivery we can actually read. The mail was always landing. We just kept learning to open more of it. And that is the secret the title of this video was keeping. What would we actually see at the edge of the observable universe? The question has no single answer, because the answer depends on the eye. Every time our species has built a new one, the old limit has dissolved, and a deeper universe has poured through. So of course you already know what the last move has to be. It is the only move left on the board. The microwave eye hit a wall that no light of any octave can cross, because behind that wall, light itself could not fly. Every eye we have ever built, from the savannah to the satellites, has been an eye for light. Different octaves, say messenger. And the messenger is done. The keyboard has been played from end to end, and the fog stands behind the last key. So we stop building eyes for light. Two messengers were in that fog, flying straight through the pinball game as if the bumpers were not there. One of them, humanity has already caught. The other would carry the deepest mail in existence. It is time to meet the eyes that are made of something else entirely. Everything we have caught tonight, every galaxy, every deep field, every pixel of the baby picture, arrived here as electromagnetic radiation, light, in the broad sense, one family of messenger, from radio to gamma ray, and we have now followed that family to the absolute end of its reach. The surface of last scattering is light's first page. Nothing older exists in that family, anywhere, in any octave, and no engineering will ever change that. But physics stocks more than one messenger, and I want to introduce the other two properly, with a discipline you have earned from me after 15 chapters of straight talk. For each one, I am going to keep 3 boxes strictly separate. What we know, what theory confidently expects, and what nobody has ever seen, because this is the frontier, the real one. And the difference between those boxes is the difference between science and a bedtime story. Messenger number 1. The neutrino. Here is a fact that sounds invented and is simply true. As you watch this, trillions of neutrinos are passing through your body every second, through your skull, your hands, the planet under your chair, and out the far side, without touching a single atom of any of it. Neutrinos are particles with almost no mass and almost no willingness to interact with matter at all. For the gentle, low-energy kind, our sun pours out. You would need a wall of solid lead about a light year thick just to stop half of them. They are, by an enormous margin, the most antisocial things in existence, which sounds like a defect until you remember the fog. The fog that trapped every photon in the universe for 380,000 years was a pinball machine of free electrons. And it worked because photons interact with electrons. Neutrinos barely interact with anything. To a neutrino, the blinding plasma of the infant universe was a light morning mist. And the hot early universe manufactured neutrinos in unthinkable quantities. Then let them go. And here is the number that matters. The neutrinos decoupled and flew free when the universe was about 1 second old. 1 second. The photons of the baby picture waited 380,000 years for the fog to clear. The neutrinos walked straight through the fog and left in the first second. So theory expects, with real confidence, that a cosmic neutrino background fills the entire sky right now. A fossil older than the fossil. A baby picture taken at 1 second of age. It should be everywhere. It should be passing through you as you hear this. Now the boxes. What we know, neutrinos exist. We detect them routinely from the sun and from exploding stars. And the physics of the early universe requires that relic background to exist. Better than that. Its presence leaves subtle fingerprints on things we can measure, on the baby picture itself, and on how matter clustered afterward. And those fingerprints have been found. The indirect case is strong. What nobody has ever done, and I mean nobody, ever, is directly catch one of those relic neutrinos in a detector. They have been slowed and stretched by expansion into a state so feeble that they slip through every instrument we know how to build. The 1 second baby picture almost certainly exists, is almost certainly streaming through your body right now, and remains, as of tonight, unphotographed by any eye on Earth. Messenger number 2. And this one. Humanity has heard. When masses accelerate violently enough, they shake the fabric of space itself, and the shaking spreads outward as ripples, waves in space-time, moving at the speed of light, passing through matter almost untouched. Gravitational waves. For a century they were a prediction on Einstein's paper. Then, in 2015, two enormous detectors in Louisiana and Washington state felt a tremor pass through the Earth. Two black holes, over 1 billion light-years away, had spiraled together and collided, and the crash rang space like a bell. When that ripple crossed our planet, it stretched and squeezed every object on Earth, including you, by less than the width of a proton. And we caught it. Humanity built an eye sensitive enough to feel space-time itself vibrate. And the eye worked. That box is closed. Gravitational waves are real. Detected. Measured. Done. Now, aim that fact at the beginning of everything, because you can already feel where this goes. The fog could not stop gravitational waves. Nothing stops gravitational waves. Ripples in space generated in the very first instance of the universe. In its first trillionth of a second, would have sailed through the entire fog era untouched and would still be crossing the cosmos tonight. Unimaginably faint, carrying direct information from an era no photon can ever describe. A baby picture taken at effectively time zero. The boxes. Honestly, what we know. Gravitational waves exist, and we can detect the loud, recent kind. What theory expects? If the universe's earliest instance unfolded the way our leading models suggest, a background of primordial ripples should permeate everything, and specific versions of those models make that background potentially findable. Either directly or through a particular twist it would print into the baby picture. What nobody has seen, any of it, as of tonight. No primordial gravitational wave has ever been confirmed. There have been false alarms. One famous claim in 2014 that dissolved under scrutiny. And the hunt is fully underway with detectors and telescopes designed for exactly this. But the deepest mail in the universe is still, as far as anyone can prove, unopened. So here is the honest map of the final frontier. And look at what has happened to our journey. All night, the limit of seeing was a limit of light. We have now stepped past light entirely. The wall of last scattering, the absolute floor of every photograph, turns out to have 2 doors in it. Behind the first door, a neutrino sky from 1 second of age, almost certainly real. Waiting uncaught, behind the second, a gravitational sky from the first instant itself. Theoretically expected, still unfound. We have reached the limit of light. Whether we have reached the limit of information is a question still open on every desk in cosmology. I want to be clear about what that does and does not mean, because this channel deals in measurements, and measurements are strict. Nobody can promise humanity will ever open those doors. The relic neutrinos may stay forever below the reach of any buildable detector. The primordial ripples may be printed too faintly for any instrument this species will ever afford. Nature owes us nothing here, but the album has stopped being provably finished, somewhere below the first page of light. There may be earlier pages, written in messengers we have only just learned to read. And the first generation of humans who could even attempt to read them is the one alive right now. If this journey has rearranged your sky tonight, this is the moment for the like button. And if you want to be here when one of those doors opens, and one of them might open in your lifetime, subscribing is how you keep your seat. 2 chapters remain. It is time to ask the question that ends this story. Suppose we had no limits at all. Suppose we built the perfect eye, the final telescope, the instrument at the absolute ceiling of physical possibility. What is the most it could ever show us? Every limit we have hit tonight, somebody somewhere is trying to engineer around. That is what our species does. We heard never and built the airplane. We heard never again and put boot prints on the moon. So before this story closes, the engineer in you deserves a full and fair hearing. Let's give it the grandest hearing imaginable. Forget budgets. Forget the physics of construction. Forget politics. Forget time. Tonight we commission the final instrument. A telescope with a mirror as wide as you please. 1,000 miles. 1,000,000. Vida. Detectors with perfect efficiency, catching every single photon that touches them. Wasting none. Zero noise. Cooled to the absolute floor of temperature. Unlimited exposure time. Point it for a century. 10 centuries. Whatever it asks. And full coverage of every messenger we own. Every octave of light from radio to gamma ray. Plus neutrino eyes and gravitational ears at the theoretical ceiling of sensitivity. The perfect eye. The last telescope. The one no future civilization could ever improve. Now aim it at the deep sky and ask the only question left. What is the most this machine can ever show us? Start with what it wins. Because it wins a great deal. The perfect telescope sees every galaxy in the observable universe. All of them, down to the faintest dwarf at the bottom of the deepest field. It resolves individual stars in galaxies 10 billion light-years away. It reads the baby picture at the finest detail the light itself contains. It maps the first stars igniting, un by un, across the cosmic dawn. It fills in every page of the album with a sharpness no astronomer alive would dare to dream about. Whole libraries of discovery, delivered every night. Hand humanity this machine tomorrow, and the golden age it opens might run for 10,000 years. And now watch closely, because here is where it stops. The perfect telescope runs into exactly 3 walls, and it cannot cross any of them, and the reasons have nothing to do with the machine. Wall number 1. The fog. Point the perfect optical eye, or infrared, or radio. Any light eye at all, past the baby picture, into the first 380,000 years. It sees nothing, and this nothing is a different animal from every darkness we beat tonight. Those were faint somethings, waiting for a better instrument. This is absence. A telescope is a net cast into the river of light that pours onto this planet. And a bigger telescope is a wider net, catching more of what the river carries. Fainter flickers, rarer arrivals, older currents. What no net of any size can ever do is pull out something that was never in the water. From the fog era, no straight flying photon exists anywhere in the universe. The river simply does not carry that cargo. Perfect collection of 0 is 0. Wall number 2. The delivery record. Aim the perfect eye outward, past the rim of the observable universe, at the galaxies we now know are out there. The ones filling that other sky we visited. The ones sitting in catalogues on worlds 46 billion light-years away. The perfect telescope sees none of them. Their light has never arrived here. Sensitivity is beside the point, because sensitivity is the art of catching faint arrivals. And these are no arrivals at all. You cannot amplify mail that is still in transit, and for the most distant regions. Expansion guarantees the transit never ends. The perfect eye is still an eye at one address. and an address only ever receives its own deliveries. Wall number 3, and this is the one that closes the case. You might suspect the first 2 walls are really one wall wearing 2 costumes, and that a clever enough civilization might someday find a costume change of its own. So let me state the deep version plainly, because it deserves to be said once. Straight. The universe has a causal structure. There is a hard bookkeeping, written into space-time itself, of which events can ever influence which other events. Light speed is the courier limit of that bookkeeping, and no messenger. Photon, neutrinos, gravitational waves, anything that carries information, moves faster. Every observer, at every address, at every moment, is therefore wrapped in a boundary drawn by that bookkeeping. A boundary containing everything that has ever been able to send them so much as one particle of news. What lies outside that boundary has done more than fail to reach us so far. It stands, as of tonight, outside the ledger of everything that has ever been allowed to touch us. Our instruments never created that boundary. They inherit it. The perfect telescope inherits it too, in full, on day 1. And that is the finding of the hearing. So let's write it down carefully, because it separates this limit from every limit our species has ever broken. When people said humans would never fly, the sky was enforcing nothing. The air was right there. The physics permitted it, and the only thing missing was a machine. Every never we have ever demolished was that kind of never, an engineering never. This one belongs to a different species entirely. The information from beyond the walls is out of reach in principle. At this address, in this era, and building harder changes none of it. Some knowledge is late. Other knowledge simply lives at addresses that will never include ours. And no instrument can change what address it lives at. The perfect telescope is a magnificent machine for reading every letter that comes to the house. It cannot make the universe send different letters. So the engineer's road ends here, at the ceiling of the possible. And the view from the ceiling is now fully mapped, which means there is nothing left to build, nothing left to launch, and nothing left standing between us and the question this entire night was named after. We have descended through every layer, changed every eye, crossed to the far rim and back, stood inside the fog, and priced out the final instrument. Time to answer the title, plainly, completely, and for good. You clicked on a question. What would we actually see at the edge of the observable universe, after everything we have crossed together? You have earned the answer with no hedging and no detours. So here it is. One final inspection. Every candidate your imagination brought to this video, held up one last time against everything we now know. Is there a wall out there? A barrier? A skin? A boundary of the cosmos? No. We went to the coordinates. We stood at the exact address our maps call the edge. And the neighborhood was ordinary. Stars and galaxies and quiet black gaps running on in every direction. The observable universe has a rim, the way a flashlight beam has a rim. The forest does not end where the light ends, and nothing in the forest marks the line. A lost galaxy, then a final outpost with nothing beyond it. No. Go deep enough and the galaxies get younger, stranger, more ragged, until you pass the first of them. And what lies beyond the first galaxy is simply an earlier universe. Dark gas and invisible scaffolding. Busy building. The census never found an outermost anything. It found an era before the things existed. Empty black space. Then a void where everything runs out. No. And this answer belonged to your own eyes all along. Every blackness we met tonight turned out to be a costume. The naked eye's void was full of galaxies. The optical floor was full of infrared infants. The infrared floor was hiding a wall of fire, darkness. At every single layer was the signature of the wrong instrument. Never the signature of nothing. A glowing shell. Then because there is that famous wall of light, the cosmic microwave background, wrapped around the whole sky. Is that the edge, a physical surface surrounding the universe? Closest so far. And still no, the glow is real. And it does mark the absolute flaw of every photograph. But it surrounds nothing. It is a moment. The moment the fog broke. 380,000 years after the beginning. Glowing from every direction because it happened in every direction. We see it as a wall around us. The astronomers in that galaxy across the gulf see their own wall around them. Built from different light of the same morning. Two walls. One moment. A surface in time. Wearing the costume of a surface in space. So answer it straight. What is the farthest thing we can actually, directly see? That moment. The light of the breaking fog. The baby picture. The surface of last scattering. That is the true flaw of vision. The deepest photograph that will ever be taken with light by anyone. Anywhere. Ever. Every deep field bottoms out there. Every future telescope bottoms out there. Ask the universe for the farthest visible thing, and it hands you its own birth portrait. And beyond it, behind the first page, here is where you get to be smarter than the question. Beyond was never a door to outside the universe. Beyond the wall lies the same universe. Earlier, the fog years. The first second. The first instant. Eras that were everywhere. Including right here. In the space your body is occupying now. Their light cannot reach us because their light could not fly. Their other messengers, the neutrinos of second one, the ripples of the first instant, may be passing through this room as you hear this. Unread. The territory past the edge of seeing is not elsewhere. It is earlier. So collect it all into one sentence. The sentence this whole night was building. There is nothing waiting at the edge of the observable universe. Because that edge was never a place where the universe stopped. It is the place where your information runs out. And it is different for every observer who has ever opened an eye. Every observer in the cosmos. On every world. In every era. Stands at the center of their own sphere of arrivals. Wrapped in their own wall of first light. Holding their own album, with its own final page. Move. And it moves with you. The galaxy we visited carries theirs. You carry yours. The universe issues one to every observer at birth. And yours has been with you your entire life. Which leaves exactly one piece of business. And it is the promise I made you in the very first minute of this video. I told you that whatever sits at the edge of the observable universe, you had already seen it yourself. Without a telescope. Possibly today. It is time to pay that debt. And to pay it, we have to go back to a spacecraft we left drifting in the dark a long time ago. Voyager 1 is still out there. While you and I fell through 13.8 billion years of stacked light. While we stood under a stranger's sky at the rim of everything and found our own home glowing there as ancient fire. The little spacecraft from 1977 just kept doing the only thing it knows. Falling outward. Through the dark between the stars. At about 38,000 miles per hour. Carrying its golden record and its 1970s electronics and its faint, patient voice that still takes almost a day to reach us. At the start of this video, Voyager was our symbol of far, the most distant thing our species has ever touched, the outer marker of human reach. So now, with everything you own after this long descent, look at it one more time. Voyager has been flying for very nearly 50 years, and it has covered about one light day. The nearest star to the Sun sits 4 years of light away. Voyager will drift that kind of distance in tens of thousands of years. The Milky Way runs 100,000 light-years across. The wall of first light, the true flaw of every photograph, delivers its glow from a surface that now sits 46 billion light-years out. Run that comparison honestly, and something almost funny happens. The farthest object humanity has ever sent, the machine that defined far for 2 generations, has traveled a distance so small against the observable universe that no illustration in this video could render it. If the observable universe were the Earth, Voyager has yet to leave your yard. It has yet to reach the mailbox. 50 years of falling, and our champion is still standing on the doorstep. One light day from the porch, with 46 billion light-years of universe ahead of it. And here is the turn I have been saving. The reason Voyager had to open this story and had to close it. That doorstep is anything but an embarrassment. Because after 19 chapters, you now know something that flips the whole picture. Reaching the edge was never the way to see it. The edge is a horizon of arrivals, drawn around every observer, and the mail from its farthest reaches is nowhere out there waiting for a visitor. It is here. It is arriving. It has been arriving the entire time. Which brings us to the debt. In the first minute of this video, I promised that whatever sits at the edge of the observable universe, you had already seen it yourself, without a telescope, possibly today. Here is the payment. The cosmic microwave background, the oldest light in existence, the glow of the breaking fog. The deepest thing any instrument will ever photograph does not live in observatories. It fills the universe. It is streaming through the room you are sitting in right now, from every direction at once, passing through your walls, your ceiling, your body. Hundreds of photons of it inside every cubic inch of the air around you at any moment. You are soaking in the edge of the observable universe as you watch this sentence. And once, you almost certainly watched it dance. If you are old enough to remember analog television, you remember turning to a dead channel and seeing static. That hissing blizzard of grey snow. A small fraction of that snow was never interference from anything on Earth. It was this, the stretched light of the primordial furnace, 13.8 billion years old, released on the day the universe went transparent, ending its journey in a living room antenna and flickering across the screen as noise. Children have fallen asleep in front of the first morning of the universe. Nobody in the room knew the channel they were watching. So the answer to the title was hiding at home the whole time. And now you can say it in one breath. What would we actually see at the edge of the observable universe? Nothing that lives out there. Because the edge lives with the observer. What we see is the oldest light that has ever managed to arrive. The glow of the morning, everything cleared. And it falls on this planet every second of every day. From the entire sky, free of charge, no telescope required. The edge of everything was never a destination. It is a delivery, and your address has been receiving it since before you were born. Tonight, if the sky is clear where you live, step outside for 1 minute. Find any dark patch between the stars. Any piece of certified nothing, the kind Bob Williams once bet his career on. You now know what is stacked inside it. 3,000 galaxies in every grain of sand of sky. Beneath them, the ragged infants of the first billion years. Beneath those, the darkness where gravity framed the future with the lights off. And beneath everything, arriving through that exact patch and every other patch at this exact moment, the light of the beginning itself, brushing past your face on its way through the room. You are standing at the bottom of the deepest photograph ever taken, and it is still developing. That is the edge of the observable universe. You live inside it. It comes to you. Thanks for making the whole descent with me. Good night.